You think you know what an alien looks like. 2 eyes, 2 arms, 2 legs, a head on top, maybe green skin, maybe gray, maybe some extra fingers or tentacles thrown in for good measure, but fundamentally humanoid, fundamentally recognizable, something you could sit across from at a dinner table and, have a conversation with. This is what Hollywood has sold you. This is what science fiction has drilled into your imagination for a century. And it is almost certainly wrong. Not just a little wrong. Catastrophically, embarrassingly wrong. The kind of wrong that future generations will look back on and laugh about, the way we laugh about medieval maps that show dragons at the edge of the world. Carl Sagan had a name for this mistake. He called it carbon chauvinism. And before you dismiss that as academic jargon, understand what he meant. Chauvinism, an irrational belief in the superiority of your own kind, a failure to imagine anything fundamentally different from yourself. We assume that life everywhere must be like life here, carbon-based, DNA encoded, breathing oxygen, drinking water, built from the same 20 amino acids, following the same biochemical pathways. And this assumption is not based on evidence. It is based on the fact that this is the only kind of life we have ever seen. But here is the problem with that logic. We have looked in exactly one place, one planet, orbiting one star, in one galaxy. That is a sample size of 1. And from that single data point, we have constructed an entire theory of what life must be, what it requires, how it operates, what it looks like. That would be like going to a single beach, picking up a single grain of sand, examining it under a microscope, and concluding you understand beaches. Let me be more specific about what we are assuming. We assume life needs liquid water. Why? Because every organism on Earth needs water. Water is the solvent, the medium in which biochemical reactions occur. It has the right properties, stays liquid across a wide temperature range, dissolves many compounds, has unusual density characteristics. For Earth life, water is essential. But Earth life is not all life. It is one implementation of life, one solution to the problem of replicating complexity. And the fact that this solution uses water does not mean water is the only possible solvent. It might just mean water was abundant on Earth when life emerged. Ammonia could work, methane could work, silicon-based chemistry in liquid nitrogen, sulfuric acid, things we have not even thought of because our chemistry is built around what exists in Earth's environment. The same logic applies to oxygen. We think oxygen is necessary for complex life. Why? Because complex life on Earth uses oxygen for energy metabolism. Aerobic respiration, breaking down glucose in the presence of oxygen, releases large amounts of energy that cells can use to do work. It is efficient. It powers everything from bacteria to blue whales. But oxygen is also toxic, extremely toxic. For most of Earth's history, oxygen was a poison. The early atmosphere had almost no free oxygen. Life emerged and thrived in that oxygen-free world for billions of years. Then, around 2.5 billion years ago, cyanobacteria evolved photosynthesis. They started producing oxygen as a waste product, and that oxygen nearly killed everything. It is called the Great Oxidation Event, and it was one of the largest extinction events in Earth's history. Oxygen is a reactive molecule. It damages proteins, breaks down cell membranes, causes oxidative stress. Life had to evolve elaborate mechanisms, antioxidants, enzymes, repair systems, just to survive in an oxygen-rich atmosphere. So when we say complex life needs oxygen, what we really mean is complex life on Earth adapted to use oxygen after oxygen became abundant. But that does not mean oxygen is required. It means oxygen was available, and evolution found a way to exploit it. On a planet with a different atmosphere, methane, hydrogen, nitrogen, life might evolve completely different energy pathways, pathways we cannot even imagine because we have no examples to study. And then there is carbon. Carbon is the basis of all known life. Every organism on Earth is built from carbon compounds, proteins, nucleic acids, lipids, carbohydrates, all carbon-based. And the reason we use carbon is simple. Carbon is versatile. It forms 4 strong covalent bonds. It can create chains, rings, complex 3-dimensional structures. Carbon chemistry is rich, diverse, capable of the complexity necessary for life. But silicon is directly below carbon on the periodic table. Silicon also forms 4 covalent bonds. Silicon chemistry is less diverse than carbon chemistry, true. Silicon compounds are less stable in water. But in a different environment, high temperature, non-aqueous solvent, silicon might work. We do not know. We have never seen silicon-based life. But the absence of evidence is not evidence of absence. Just because we have not found it does not mean it cannot exist. Look, I am not saying silicon-based life is common. I'm not even saying it is likely. I am saying we do not know. And the fact that we do not know should make us humble, should make us cautious about declaring what life must be. Because every time we say life must have this property or that property, what we are really saying is Earth life has this property, and we cannot imagine anything different. This is the trap Sagan warned NASA about. When we design missions to search for life on other planets, what are we looking for? Water, oxygen, organic molecules, by which we mean carbon-based molecules. We point our instruments at Mars and ask, is there water? Are there signs of oxygen production? Can we detect methane or amino acids? And these are reasonable questions if we are searching for Earth-like life. But what if life on Mars is not Earth-like? What if it uses a completely different chemistry, a different solvent, different building blocks? Our instruments would not detect it. We would fly right past it and declare the planet dead. This has happened before. In the 1970s, the Viking landers performed experiments on Martian soil. One of those experiments was designed to detect metabolism. The idea was simple. Take a sample of Martian soil, add water and nutrients. If there are microbes in the soil, they should metabolize the nutrients and release gas. The experiment was performed. Gas was released. By the criteria of the experiment, the result was positive. There was biological activity in Martian soil. But then other experiments produced confusing results. No organic molecules detected. No clear signs of life. And so the scientific community concluded the Viking results were a false positive. Some unknown chemical reaction, not biology. And maybe they were right. Probably they were right. But here is the uncomfortable question. What if they were wrong? What if the Viking landers detected life, and we rejected the result because it did not fit our preconceptions, because the life did not behave the way Earth life behaves? I want to be clear. I am not claiming Viking found life on Mars. I am saying we might not recognize life if it operates on different principles than Earth life. And that is a problem, because when we search for extraterrestrial life, we are not really searching for life. We are searching for life as we know it, life that fits our definitions, life that uses our chemistry, and anything that falls outside those boundaries is invisible to us. Think about what this means for how we imagine aliens. Every depiction of extraterrestrial intelligence, movies, books, games, shows beings that are fundamentally like us. They have bodies, discrete bodies with boundaries. They have senses, usually vision, often hearing. They communicate. They use technology. They have goals, motivations, conflicts. They are, in other words, recognizably alive in a way that we understand. But why should alien intelligence resemble human intelligence? We evolved on a specific planet with specific conditions: gravity, day-night cycles, seasonal variations, predators and prey, social groups. These conditions shaped our evolution. They determined what traits were advantageous. Vision is useful because there is light. Hearing is useful because there is an atmosphere that transmits sound. Limbs are useful because there is a solid surface to move across. Social behavior is useful because we are mammals that rear our young, but on a different planet. With different conditions, evolution would favor different traits. On a high-gravity world, large bodies would be disadvantageous. Life might be small, close to the ground, built to withstand crushing pressure. On a world with a thick atmosphere, flight might be common. On a world without a solid surface,
a gas giant perhaps. Life might never develop anything resembling a body at all. It might be diffuse, spread across volumes of space, something more like a weather pattern than an organism. Or consider a world where the primary energy source is not light but chemical gradients, geothermal vents, subsurface oceans. Life in those environments would not evolve eyes. Why would it? There is nothing to see. It might evolve chemical sensing, or electrical sensing, or something we have no name for because we have no sense that does it.
And this is just talking about biology, about physical forms shaped by evolution. What about intelligence itself? We assume intelligence requires brains, centralized information processing, neurons firing in patterns. But that is how Earth animals do it. Plants do not have brains, and yet they process information. They respond to their environment. They communicate with each other through chemical signals. Fungal networks extend underground, connecting trees, transferring nutrients and information across forests. This is not intelligence as we define it, but it is complex information processing nonetheless. And on another planet, intelligence might not require neurons at all. It might be distributed, emergent, something that arises from the interaction of many simple components rather than the operation of a single complex organ. Take it further. What if intelligence does not require biology? We are made of cells. Cells are made of molecules. Molecules are made of atoms. But there is nothing sacred about this particular arrangement. You could, in principle, build an information processing system out of anything that can store and manipulate states. Mechanical systems, electrical systems, quantum systems. A sufficiently advanced technological civilization might transition from biological intelligence to synthetic intelligence. And once you do that, the constraints of biology fall away. You do not need water. You do not need a habitable temperature range. You do not need a planet at all. You could exist in space, in the cold, in radiation that would kill any biological organism instantly. Now, this might sound like science fiction, and I suppose it is, but the point is not that these scenarios are likely. The point is that they are possible, and possibility is what we should be attending to when we think about life in the universe. Because the universe is vast. Hundreds of billions of galaxies, hundreds of billions of stars in each galaxy, more planets than we can count. And on those planets, every possible chemistry is being tried, every possible combination of conditions. If life can emerge from those conditions, it will, and it will take whatever form works in that environment. We keep asking, where is everybody? We scan the skies for radio signals. We look for technosignatures, signs of advanced technology, and we find nothing. The universe appears silent, empty, dead. But what if we are looking for the wrong thing? What if intelligence in the universe does not use radio? What if it does not build machines we would recognize as machines? What if it communicates in ways we have not thought to look for? There is a deeper issue here, a philosophical issue. We assume that life and intelligence are rare, that the conditions necessary for life are narrowly constrained, that Earth is special, privileged, one of the few places in the universe where the chemistry is just right, the temperature is just right, the conditions are just right for life to emerge. And maybe that is true if you define life narrowly. If you insist life must be carbon-based, water-dependent, oxygen-breathing, but if you broaden the definition, if you accept that life might use different chemistry, different energy sources, different organizational principles, then the conditions for life become much less restrictive, and life might be common, abundant, everywhere. But if life is everywhere and we do not see it, what does that mean? It means we do not know what we are looking for. Our search is like a person who has only ever seen birds and insects and concludes that flight requires feathers or wings, and then fails to recognize an airplane as a flying object because it does not fit the pattern. The airplane is there, visible, functional, but the observer's categories are too narrow to include it. We are that observer, and the universe is full of airplanes we are calling birds. Sagan understood this. He spent much of his career arguing for intellectual humility, for recognizing the limits of our knowledge and our imagination. He was cautious about declaring what must be true based on limited evidence. He knew that every time science has been certain about some principle of nature, some boundary that cannot be crossed, nature has found a way to violate it. Not the laws of physics, those hold, but our interpretation of what those laws allow, our sense of what is possible. And when it comes to life, we are still at the very beginning of understanding what is possible. We have one example, one data point, one implementation, and from that, we are trying to extrapolate to the entire universe. That is not science. That is guesswork. Educated guesswork, perhaps, but guesswork nonetheless. So when you imagine an alien, stop. Stop picturing something with eyes and arms. Stop assuming it breathes. Stop assuming it has a discrete body. Stop assuming it thinks the way you think, because the odds are overwhelming that if we ever encounter extraterrestrial intelligence, it will be so fundamentally different from us that we will struggle to recognize it as life at all. It might not communicate in ways we can detect. It might not value the things we value. It might not even perceive the universe in categories we understand, and that should not disappoint you. That should excite you, because it means the universe is stranger than we imagine, more diverse, more creative, more full of possibilities than our limited earthbound experience can encompass. Life does not need Earth. Life does not need our chemistry, our atmosphere, our conditions. Life needs only the right physics and enough time, and the universe has both in abundance. What life becomes under different conditions, we cannot say. We have not seen it yet. But absence of evidence is not evidence of absence. Just because we have not found it does not mean it is not there. The carbon trap is the trap of assumption. The trap of thinking our way is the only way. The trap of extrapolating from one example to universal law. And it is a trap we must escape if we want to truly understand life in the universe. Because until we do, we are searching with blinders on. We are looking for ourselves. And the universe, in all its creativity, has almost certainly invented something more interesting than that.